introduce you before we start. My name's Esther White. I'm the CEO of Maths Australia, have been for the last 24 years, and I'm joined tonight by Bethany, who's actually going to be here, and she's going to be able to put links in the page, in the chat, answer any questions as we go through, and then Bethany will be the main contact person if you have any questions after tonight. So thank you, Bethany, for your support for us to do this. And just want to welcome you to tonight and thank you for coming. As you have seen on our website, tonight we're going to talk about the smartest way to teach maths. And basically what we're going to be looking at is a response to intervention approach that looks at research and tells us what are the key components that we actually need to have when we're teaching students mathematics. So we're going to look at that. We're going to look at those three components that were talked about on the website, where we're looking at maths being a language, the symbology that's in maths. We're going to look at some of the key components of intervention, as I mentioned, and then you're going to also have the opportunity just to see the simplicity of this approach that I'm going to be sharing with you tonight. So what I'd like to invite you to do, I mean, it's a webinar, but we've done it, as you can see, as a meeting where you can actually add questions in. We can actually see you, which I absolutely love because I get to interact a bit more. So I just ask you, if you have questions, just to pop it into the chat and we can ask them. I'll be answering questions as we go along at different times. And then also we'll have the opportunity, as I said at the end, for me to actually answer those questions a little bit more. So how's that sound to everybody? All good? Great. Okay, and what I'd like to ask you, first of all, just while we're waiting for a few more people, is if you can pop into the chat, what's your key area of interest? Like, what was the key piece that brought you to say that you wanted to join this program, this webinar tonight? And also wanted to mention, so if you can just do that while I'm chatting away. So the key piece that was of interest to you, just so that I can make sure that I'm actually addressing those, and I'm pretty sure that I will just from what we've shared. So thanks, Marianne. Maths intervention, great. Anne said helping students with dyscalculia, fantastic. Starting an intervention program, awesome. Thanks, Melinda, great to see you. Teach an integration class, working with vet students, wonderful. Okay, great. So what we're going to do is I'm going to share some slides sometime through tonight. As I'm sharing the slides, I'm going to also stop those slides and then switch over to another camera where I'm actually going to show you with this manipulative that we recommend you use, that basically can reduce cognitive load so significantly for a student just by using this one approach where we're building a rectangle and we're counting. So that one manipulative that can be used to teach all of whole number understanding of all operations. And I'm going to actually have some manipulatives here and show you these manipulatives because they really are the starting place, particularly when we look at teaching from a concrete representational abstract space, but particularly as well where we are teaching maths as a language. So let's get started. I'm going to keep looking back to my chat to see if there are any questions that come up, but I'm going to share my screen with you now and then we'll get going. So let me just do this. Okay, can everybody see that screen okay? Yes, great, okay. So let's look at, as I mentioned, we're going to look at this response to intervention model. And basically the reason that we're doing that is because we're wanting to use an approach that can actually be taken for a student, not only in their intervention one-on-one, but also in a small group up to 5 students we recommend, but also in a classroom setting. So we want that consistency for the student to be there. But even if we just have the student for an intervention space, we're going to actually use research and the greatest recommendations that there are in terms of what a student needs for them to be able to understand maths. Then this part that I mentioned where we're going to teach maths as a language. So I really invite you to get a piece of paper out and a pen and have that available for you just to work with as we're going through, this importance of us actually knowing that we learn best as well when we learn in a multisensory way. And then I'm going to share with you the I-CRAVE methodology, which is basically, I suppose, a summarized way of teaching, incorporating these recommendations, not only for response to intervention, but particularly intervention when we look at students with dyscalculia or other learning differences. And you'll see within that I-CRAVE. So we're going to talk about that, but we're going to talk about that in a much more explicit way than you might have heard it talked about before, because there's a difference, even if we can use the word explicit, but there's explicit that's actually very accurate, and there's explicit that then will have to be undone later. So we're going to talk more about accuracy and really being very aware of what we're teaching, how we're explaining components to our students. And then, as I said, we're going to look just very simply at lesson planning. So let's look at this component. Basically, when we look at response to intervention, we're seeing that the key component for a student is high quality teachers, so the importance of professional development. We're then looking at an evidence-based approach where we differentiate the student and we monitor the student as we progress. So the differentiation, I know that we're aware as teachers that we can differentiate and then differentiate again, and we can continually just sort of differentiate between students. But what we're wanting to ideally do, and you'll see as we go through tonight, we're going to look at this sequence of instruction and see that we can differentiate to a level of mastery for a student so that we can then address the gaps, but teach confidence and accuracy and understanding along the way. And then this component where we're wanting to intervene early at the student's point of need. So that sort of comes back to differentiation as well. So just as a really short recap, I mean, have many of you heard about response to intervention and are aware of these 3 tiers within RTI? Yeah, cool. So basically, just as a summary, we've got our core classroom, which is the tier 1, our targeted small group intervention, which is tier 2. And as I said, we recommend up to 5 students as a maximum, because beyond then, you actually don't get to really see whether a student's incorporating or understanding the lesson so much. And then tier 3, which is our intensive and individualized instruction. So it's much more for those students that haven't been able to learn in that small group and then needing further intervention. And this is just a graphic representation of that I just mentioned there. So ideally, we would have this proportion of students, although what you might see in your schools is that often this is flipped up the other way, this little pyramid where we actually have a lot of students that may need more tier 3 intervention, one-on-one or small group intervention, and smaller numbers. So it's not necessarily an upside down pyramid, but maybe, the smaller, the tier 3, smaller number of students in tier 1 and a large group of students in tier 2. And we tend to find that when we've had the opportunity to go in and test schools, entire, primary school, for example, where a lot of the students are right back at this point of needing to be able to finger count, or they are finger counting, or they haven't actually progressed from finger counting into addition, or they don't understand place values. So some really key components, but you'll see that as we progress. So when we look at these response to intervention recommendations, you'll see on the screen, this part where we say we need to screen the students. And I'm going to share with you a way that you can easily screen, and we're going to screen for mastery. So when I talk about mastery, I'm saying, can a student take an everyday life question, make it into a maths problem and get the exact answer? Or can they take an algorithm or something that's written in the abstract and then also apply that to their everyday life? So we want them to be able to put into code form or into symbolic form and also take from the symbolic form into their everyday life and have confidence with that. You've been able to read these other components as I've been talking. So focus on whole numbers really early and multisensory approach. And I'm talking about multisensory in terms of the ability of the student to touch and feel and see and understand, not so much a screen where, you know, if I can move something around on a screen, it's not really multisensory as much as you'll see these blocks that I'm going to show you. So that component where we know that we learn best if we can incorporate all of our senses, and also that we actually learn through images and we learn through pictures and remembering pictures. Explicit and systematic, so that I'm going to walk through this, you know, sequential approach, and that we're going to talk very accurately and explain very accurately to a student, because particularly for those students that require intervention, they have so many other components where they're almost on a hyper alert to look for the differentiations, that our instruction needs to be even more accurate and even more, you know, without the parts that we can sort of tend to get away with just because we're, you know, we've worked out our own ways of understanding maths, but we know that we've got students, we're putting ourselves into their shoes and saying we have to actually teach with accuracy and be very aware of our languaging and how we're showing you, so that you don't look for the differentiations, so that they don't look for, you know, the errors or the components that we might not even be aware of, that we're teaching them in the midst of trying to teach something else. The other part where we're looking at cumulative review and also progress monitoring. So I just wanted to share those just so that you had an awareness that we're going to incorporate those into this approach. So let's look at this part of maths being a language. So basically, if you look at the dictionary definition, and if you've been on one of my calls before, I always bring this up because it's such an important piece for us to realize that maths actually is a language. And when you look at the definition of a language, each language has its own code or its own symbols and, you know, rules or laws or standards that are included in that. Say, for example, in the language of English, we read left to right. That's just a standard that we do. In the language of maths, we also read left to right. When we look at some other languages, we read right to left and up the page. We also look at maths in terms of seeing that it's a language because it has its own specific symbols. So let's look at this a little bit more. And I've just put this on the page here, and some of you that are familiar with other languages would be familiar, even if you look at the CHIEN, the AUB, we all know those because we know the language of English. But even in these languages, like the CHIEN is actually a French word, AUB is another language word. You can see there the Japanese symbols, there's Yiddish, there's Hmong from Thailand. But basically what I want you to see with this is that all of these symbols mean absolutely nothing to you until you've actually had a hands-on experience, or you've seen or touched or felt, and then walked through what we're going to look at in terms of the CRA approach. So this, even though you might be familiar with the symbols, if you saw, for example, CHIEN, you would not know what it meant until you'd actually been walked through that process. Do you get what I'm talking about here? I mean, even if you write down those symbols on your page, you'll see, you know, I can copy this Japanese symbol, but I don't know what it means. But it actually refers to this, a dog. And in the language of English, we use these symbols, DOG. And what I want you to see from this is that DOG, they're just abstract symbols, aren't they? You know, in another language, they could mean something different. Like in the language of French, DOG would not mean the dog that we have as our best friend, or that we related to, that we drew pictures of, that we saw movies of, that we walked with, that became our best friend. That then by the time we came to this point, our abstract, DOG Now, when we see those symbols, we can decode that and have understanding because we started with and we had an understanding of what a dog was. So do you get that piece? And are there any questions about that? Because it really is a critical part, particularly when we're looking at simplifying mathematics and making it the simplest language in the entire world for a student to understand. Let me just check my chat. Okay, cool. Great, so let's look at this. What I want you to do now then, when you look at these symbols, these are the symbols that we use for mathematics. So, you know, our 0 to 9, our plus sign, our minus sign, multiplication, division. What are some other symbols that you can think of in maths language or in the language of mathematics?
The little 2 for squared.
Yeah, the little 2 up the top for squared. Yeah, that actually tells us that we've got 2 factors in something, or you know, the 3 squared. When we look at this with the manipulatives, we actually can build a square that has 3 across and 3 high. So it's
this long division thing. I don't know, that long.
Yes, yeah,
I'm too old-fashioned now.
Yes, long division symbol, exactly. And basically we can actually decode that as well and see, once we've looked at multiplication, you know, when, as I mentioned at the beginning, we're just building rectangles and counting. So if you imagine a rectangle that's like 3 across and 5 high, then we've got 15 square units in that. If we know that we've got 15 square units and we know that one side of that rectangle is 5, we're just needing to know how many 5s can I subtract from 15, or how many 5s are there in 15, and I can build it. And basically that symbol actually shows us that we're building a rectangle. We've got inside the rectangle, like if you were to join those other dots, you've got a rectangle there. You have a certain number inside that rectangle, and you know one of the factors or one of the sides of the rectangle, you need to find the other. And another reason why, once we've taught multiplication first, for example, then we can teach division with ease. Yeah, lots of other symbols out there. I mean, you know, a square root symbol where we're actually finding a square. We have the number of units in it. We're finding what shape, this square shape, what are the sides of that square going to be if I have this particular number of units in it? And I'll be able to show you one of those when we get to the blocks. So yeah, I've got the greater than, lesser than, pi, our parentheses, exponents, exactly, equal sign, percentage sign. Yeah, when you start to see this, they're just symbols that we can actually teach understanding of, and then get to the symbolic stage with meaning and with knowledge and being able to build it. And we're basically just putting into language form or into symbolic form something that we've understood. Yeah, I've got written some here as well, just for you to see. So those symbols that are there. So what I want to show you with this part of symbols and the fact that we're teaching a language is, imagine if you could use these little manipulatives, and you know, many of you would have seen probably Cuisenaire rods that had different colorations, but the key piece that that you'll see here with these manipulatives that we use is that you can see the demarcations in the actual block. So basically, when I look at the numeral 2, for example, so if you write down on your piece of paper 2, you'll see within the numeral 2, there's no inherent meaning whatsoever in that. I couldn't say to a student in front of a numeral 2, tell me what this is, if I hadn't actually given them an understanding beforehand. Whereas if I have, you know, here's my little 2 block, this is what it is, this is 2. And whatever my unit is, another piece where we say we're going to teach to a unit of measure, whatever my unit is, if I know that this is 2, for example, then if I add it to 3, it's always going to be 5. So this part where we can have accuracy, and as I said before, we're going to reduce cognitive load, have a consistency of color in the manipulative, because we know that color assists us to memorize and to remember, and we know that color assists us to learn. So we're bringing both of those together and saying, if we have this one manipulative that we can use that can actually reduce cognitive load and give us a model that's going to be accurate, that's going to be able to progress the student through from counting to place value to addition, subtraction, multiplication, division, and give a framework that when I get to fractions and have just one more kit, that model is going to still hold and enable me to add, subtract, multiply, divide my fractions, my decimals, my percents, and bring meaning to these symbols. So you start to see this piece and go, well, maybe maths actually is the simplest language, the simplest subject for us to teach students, and we've just complicated it by going straight to abstract and trying to teach, for example, rote memorization, when we know particularly students with intervention needs very often have poor working memory and need to be taught in a different way and can't actually be taught the way that other students seem to be able to get around those components. Yeah, really key piece. So what I want to share with you, how we're going to look at this, we're going to teach sequentially. So as I said, that progression through from counting and really seeing when I count, I'm just teaching the words and the symbols that I use in the sequential way of counting in our base 10 decimal system. So we're basically setting up the framework for this language of maths. The mastery approach we're looking at, where we're going to ensure understanding at every single step. And CRA, I mean, you can read through these pieces yourself. Explicit instruction, we're incorporating cognitive load theory, incorporating Rosenshine's principles, which really just a good teaching practice. And we're going to use our best practice for teaching language and say, we can now overlay that into how we're going to teach maths. So this is the sequence of instruction that we basically recommend. And as I'll show you with the manipulative shortly, there's a very simple sequence of progression here. So with counting, for example, I want the student to be able to count from 0 to 9. So we're going to show that pattern of accuracy where they can rely on and they know from just basic one-to-one correspondence and using a block that's exactly the same, no differentiations in the block, because we just want them to learn number and a number sense. Then we're going to teach place value, and we're going to teach a framework that has hundreds, tens, and units as our repeating pattern. And if you think of, I mean, we go through this in the training in quite a lot of detail, this part where we have units. In our units place, we can only have 0 to 9. In our tens place, we can only have 0 to 9. In our hundreds place, we have 0 to 9. And there's accuracy in how we're going to represent that as well. So that repeating pattern, we can teach very simply. I mean, I still remember working with a school in Caloundra on the Sunshine Coast in Queensland, where after about 3 weeks, I was there and they'd just been working with their year 1 students teaching place value. And we had a whole lot of blocks out on the table and on the floor actually. And these little children, I was able to say to them, they build for me 362, and they'd get out 300, 6Ts or 610s and 2 units. They have an understanding that's proportionately accurate of that number. And I see it time and time again when we teach with accuracy and lay down these little foundations, that the student actually has the opportunity to understand and be able to decode and decipher this language that we're teaching. So basically then the third lesson, even when we're teaching students with intervention, is teaching these blocks. So say, for example, as I said, this was my 1, and I'll show you that with the other camera shortly, but this is 1. This is 2 and it's orange and it's never going to change. I can see the demarcations. I can put another block on there. I can see 2 blocks, that's 2. Then my 3, for example, this is 3 units. I can put 3 units there. This is 3. So for me to be able to add, I have to have that understanding of this is 2, this is 3. I'm adding them. I'm bringing, if you look at the addition symbol, it's 2 lines that are brought together. I'm bringing these together Now I'm building my equal symbol, and I can show that that's the same length as or equal to my 5, and it's never going to be anything other than that. So that's a key piece, that understanding the integer, we do not want them to, or we don't want ourselves to think that they know addition if they're looking at 1, 2 plus 1, 2, 3 is 1, 2, 3, 4, 5. They're still counting, even though they might be able to write 2 plus 3 equals 5. The plus sign is 2 lines. Every time we're adding, we want them to bring just 2 numbers together, 2 plus 3, to build what's going to be the same length as, basically to recreate an equal symbol and know with confidence, which we can in maths, that that's the only answer that we're going to be able to have. So you see this part where we're starting at counting, then we're fast counting, which is addition, teaching the inverse of that, subtraction. We're fast multiplying, fast adding, which is our multiplication. So instead of me saying 3 plus 3 plus 3 plus 3 is 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, I can actually build a rectangle and see 3 counted 4 times. I think there's a couple of people on the call who I was talking with them from a school and actually looked at the with their sort of prospectus on mathematics, and it's interesting to see they've actually got this outlined in their documentation, that this is the approach that they recommend taking as well. So even without an intervention approach, you can see the simplicity and the natural progression that there is in mathematics. And as I was saying, we're just building bigger rectangles and able to count. Sometimes we count slowly, sometimes we can count faster, but that model where we're using a rectangle is always going to be accurate and always going to enable me to understand the symbolic abstract with much more confidence. And then as you can see here, division is the inverse of multiplication. Then we're teaching fractions, then decimals, which is a fraction in a base 10 linear model, and then percents per 100. So really simple approach. Just want to see if there are any questions just from that. Okay. Somebody's just asked about colour blindness. So let me just identify a talk to colour blindness. It's funny because, you know, often students with colour blindness aren't fully colour blind. Often, I mean, it's very, very rare for you to find somebody who just sees grey, but often if they just see grey, there are shades of grey. So, you know, I was working just actually an hour ago, was on a call with one of the teachers that is going through a training with us, and she works with deaf and blind students. So imagine that piece where you're trying to teach maths to these students the abstract way, and the results that she's seeing, when we're just going to use a manipulative that's accurate, that we can teach all of these components. But coming back to the colour blindness, the key piece is that the colour in the blocks just is there to differentiate the block. So the student, even if they can't, if they really truly weren't able to see any difference between the colour, then we would see that with me being able to actually, you know, just feel this block, even if I close my eyes, and we actually get the students, when we're teaching them this understanding of the integers, we play a little game where we put the blocks into a bag. We say to them, okay, find me the block that's the same length as 3 units joined together. They put their hand in, feel around for it, maybe feel a few different blocks, and they'll have to feel and come to know that 3 is 3 units joined together. It's pink, so if I know the colour, it's helpful. We're just using the colour to help differentiate and to assist our memory. Yeah, so does that answer that question? I mean, it's often asked because the colours are so distinct, but the key piece is that we have consistency of colour and consistency of the model, and that we can see those little integer demarcations there for the student. Let me just check that was whoever asked that question, if you want to just see if that was answered adequately for you. Okay, so let's go through. I just want to share with you this I-CRAVE methodology. So basically, this is it in form at the moment. And I'm going to just walk through each of these components. And many of you would have probably heard about the CRA approach, but what I want to share with you is a much more accurate way of looking at CRA. So the first part, if you want to, I really encourage you just to support your own learning, is if you write down on your piece of paper, I-CRAVE. And, you know, I was looking for an acronym that we would remember, and all of us at some time in our lives have craved something like chocolate or a holiday or something like that. So if you just think I-CRAVE, and this becomes a model that you can use for being able to teach every lesson that you're going to teach, really. So really happy with this, you know, ease of being able to remember this way of teaching. So identify, as we said, we're going to identify their current level of mastery. We're basically saying there's no point me trying to teach multiplication, particularly rote multiplication, if my student doesn't actually understand the integers or hasn't actually made that transition from unit counting. It just becomes a memorization exercise, and it really doesn't support the student. Actually means we're failing them because we're not giving them an opportunity to understand. So as I mentioned, we have these placement tests that enable you to very easily identify where the student is placed. The C is the concrete component. So this is where we use the manipulatives. And as I said, you might have noticed behind me, I've got these two manipulatives. So we've got one manipulative that's in magnetic larger form, and also there for a student, the ones that I'm going to show you. And then another manipulative that we use for teaching the fractions, decimals, percents, and algebra. The research that I've seen on manipulatives also reaffirms and confirms this need for us to use one manipulative consistently for a minimum 3-year time period. So really it says we want the student to have confidence in the tool. We don't want them to have to relearn the new manipulative that we might think is great, that we might think is interesting, but we, particularly when we're teaching students for intervention or that need intervention, they're at a point going, please just teach me accurately and clearly and simplify it. So our job as educators is to simplify the maths for them, teach them accurately, and enable them to have confidence in that approach. So we're going to use this manipulative and start every single lesson with the building component. So you'll see that little graphic that we've got there where we're starting with the building, then we're going to go to the next stage, which is our representational or pictorial. So you might have heard of CRA or CPA. Often this is talked about as a couple of things I've seen I just want to draw your attention to, and for you to be really mindful of when you're looking at this representational or pictorial component, is that this representation that we actually want the student to draw their own representation of what they've built. So it really becomes a very strong link from the concrete. If you think of this for a student where I've touched, I've felt, I've seen, it's hands-on, it's tactile, I've learned something, to then jump to the abstract is a very big jump for them. You know, symbols on a piece of paper that don't have anything, any relationship, that look similar even to those blocks that I've worked with. So in our representational or pictorial component, we want the student to draw an accurate representation of what they've built. So for example, I mean, I saw a printed text that a specialist did, a dyscalculia specialist, where they were talking to, or they were saying, you know, when we've written abstract, a number like 134, for example, and if you write that on your piece of paper, 134, the symbols, and they had a picture of it. One was with bundles, which are, if you think for a student that's struggling to understand and needs to be taught accurately, bundles are quite inaccurate unless that student has actually bundled and they have a tactile experience of that bundle. When they look at it two-dimensionally, the 1 unit and the 10 bundle do not look 10 times, this does not look 10 times the size of my unit, and my 100 does not look 100 times the size of my unit. So basically they had this picture of 100, 3 10s, 4 units, where the 3 10s was about the same size as the 100, and the 4 units was about the same size as one of the 10s. So basically then you've just right then immediately taken away the student's opportunity to understand our base 10 decimal system, where every time we move a number to the left, it's 10 times bigger. But when we draw and we're working with a manipulative that's very accurate, we want them to draw a representation that's just as accurate before we go to the abstract. So that's going to be the piece that will create that link where I've built in the 3-dimensional. Now I've drawn a 2-dimensional picture that's going to look the same as those blocks, and I'm even going to color them in. And then I'm going to go to my abstract. Let me just get a drink of water. Okay. So really key component, if you're looking at CPA or CRA, please, that's the key difference, and something we very strongly recommend is that you actually have the student draw what they've built. And when we have a tool that's so accurate and the color consistency, it becomes a very simple component, but it enables us to create a very strong link, as I said, between the concrete and the abstract. So our next piece was the abstract or the symbolic stage. And basically this is the part where we put the concrete into code form, the part where we take what we've touched, we've felt, we've seen, and we put it into the symbols that we use specifically in the language of maths. And it basically just enables us to communicate. The V is for the verbal, so the auditory learning. And we know from, our own practice, we know from research that when a student hears their own voice, they actually retain knowledge more. But also when we have this, almost like a explicit direct instruction approach, we're going to actually test and see, have they really understood what I've taught? Have they been effective in my instruction? What did they take from this lesson? Now I can take that knowledge and then adjust it as a teacher that understands what I'm teaching. Then our E is coming back again to the explicit component. So making sure that we're clear, making sure that our instruction is very accurate without any error, and that it lays a really strong foundation. And, as I said, we go into this, reminded particularly of when we're teaching fractions, we can teach ratios. Like I've seen these blocks even used by somebody to teach ratios, and they were trying to show equivalent fractions, but the ratio was accurate, and they were teaching ratios, but not actually teaching equivalent fractions as accurately as is possible, for example, with our advanced kit. So that model, that explicit, the I-CRAVE component basically is wrapped up here in this little graphic. We're going to build, we're going to draw, we're going to write, sometimes we'll spell, and we're going to say it and teach it and make sure that there's a real accuracy between all of those. So just coming back here, sorry, I didn't realize. So let me just check my timing. Okay, cool. So I'm going to do a little piece here where I'm going to just walk through these sequential components, and then I'm going to come over to my camera and show you those components. Do you think, let me just check if there are any questions before I do that. Great. Okay. So what I want you to see is, particularly as I'm showing you the manipulative, is for you to see not only the beauty of this one manipulative that we can, as I said, reduce cognitive load immediately just by using a tool that the student has confidence in, that we can use to teach accurately, but also they're not having to learn a new piece, and we also know that we're progressing them. I've seen quite a bit lately, some focus on, teaching with dots or teaching you know, different patterns that are on cards, even playing cards, for example. And what I want you to get in the habit of is to look at these and go, what am I actually teaching? Like if I look at a card that is the same size as another card, and this one card has 5 dots on it, or, you know, 5 symbols on it in a particular pattern, and this other card that's exactly the same size has 2 dots in a different pattern, what am I teaching them? I'm teaching patterns, and I'm teaching memorization or an ability to differentiate a number through pattern, but I'm not as strongly giving them a sense of number as if I was to use a manipulative where this is a 5, this is a 2. I can see what the difference is between 5 and 2. So great tool if we want to teach patterning, but you know, we're not going to always see the sheep on the field that we're wanting to count, or the kids in the field that we're wanting to count, or anything else in that pattern. And the fact as well that we have a base 10 decimal system. You know, I look at 10 frames, for example, I go, why have we brought in this piece where we're teaching 2 rows of 5 dots? So to look at that, when you look at this manipulative, I want you just to have a look as I'm walking through to see the simplicity of progressing a student through this. Yes, being able to, once they have the foundational number and algebra component understood, great, we can use manipulatives and other representations, but we want that understanding first of all. So let's look at this counting 0 to 9, as I mentioned. We're going to start with 0. And the reason we're starting with 0 is because that is the smallest number that we can have within each place in our decimal system. So, you know, 0 to 9 in our units place, we can have 0 to 9 in our tens, in our hundreds, etc. This pattern that is there, we're going to begin with 0 and be able to show that even in number charts, because we want an understanding of the patterns that a student can rely on in mathematics. So let me just come over to this. Actually, let me come back here. Let me just come to, I'm going to stop my screen share and take you to this little video camera here. Okay. So you can see this here. Here, and the key piece that we're looking at, and I was at a special school about 2 months ago, a month ago in Melbourne, and we were looking at this where some of the teachers said, what about, you know, using ducks or some other representation? Key piece that we're looking at here, and I'll come back to answering that shortly. Hopefully you'll see this as I'm looking at this. But basically this part where each of these unit blocks is exactly the same. There's no differentiation between any of them. So now we can teach number sense. We can teach an understanding of the fact that with this, we're going to count from left to right or right to left, whichever way, it doesn't matter. But when we have it in this form that's almost like it's a rectangular shape in part, we actually can easily teach one-to-one correspondence, and we're just teaching how 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can see with this number here isn't 3. You can see that, yes? This is our third number, but it's only 3 if I have 1 and 2 before it. This is 3, the same as my little pink block. But this part where initially we're just wanting to teach an understanding of what are the words and what are the symbols that we use in the language of mathematics. So this is our concrete part. We'd have the student draw a representation and write in the abstract. Let me just come back to this other camera. So just to say, when I was at this school in Melbourne, you know, this part where they actually had some big dots that they had, and we're using them to sort of teach some counting. And sometimes some of the dots were red, some were yellow, some were blue. Key piece is that, you know, it was quite interesting actually, because one of the yellow dots had a hole in it and a bit that some other part that had fallen off and it wasn't all there. And what we saw is the student will look for those differentiations. So when we have a little block that's exactly the same size, exactly the same color, exactly the same shape, you know, not something like buttons that have all different shapes, all different sizes, all different numbers of dots, all of that, where the student will look for the differentiations, they actually can have accuracy and learn the number before we bring in these other components. So really key part when we're looking at teaching counting, we just are teaching the language and the symbols that we use, that order of counting in mathematics and creating that first foundation. And as I mentioned, like we go into this quite a bit more when we are working through the training. Okay, let me just come back to the slides here. I just saw there was a question, so let me just answer that. Okay, so Brenda's just asked, what if they're not able to draw their build? Totally fine. I mean, the thing for us to see, Brenda, I mean, what we've done, say, for example, at this special school, and you can do, if they're not able to draw that because of some physical disability or, you know, the piece to see is we're not teaching geometry. So we could use like grid paper, for example. Sometimes what we're doing is even having a representation of the blocks on a piece of paper and the student just pointing to that particular block and then pointing to the numeral that it represents. But we're still creating that link so that the concrete is a starting place. That's where the learning, that's where the understanding comes from. Great. Yeah, great question. Okay, this part then where we're going to teach place value, and I've talked about this a little bit, but our exceptions of our teens and, you know, these strange words that we use where we change, instead of saying the value and then the place, the value of 9, the place of tens is 9t. When we get down to 3 tens, instead of calling it 3t, we call it 30, or 2t, we call it 20, or 1t, we call it 10. And, you know, when you look at teen numbers and we teach this part explicitly, it's really important because we want to teach that accuracy and we want to teach the student that they can rely on this approach and we can rely on mathematics. And in some names, like, for example, the teens, 30, 20, and 10, we have what we refer to as nicknames. So that's a really key piece when we're teaching that, so that they can understand the language that we use and be able to decode that language. Okay, so this addition and subtraction, I just wanted to show you as well with the blocks. So let me come back again to this, but when we're introducing addition, we want to introduce, as I said, the equal sign and also the plus sign, which is, as we see, you know, two lines that are brought together. We're always only bringing two numbers together to see what are they the same length as or equal to. So let's come again to this other camera. I'm going to stop this again. Hang on, let me just pop this here. Okay, so I just wanted to show you this here. You know, once I know, for example, that this is a 2 and that this is 3, and I'm wanting to add these together, I'm just going to bring these together to see what are they the same length as or equal to. Can you see this? I mean, this is the part where we talk about discovery learning for students, and we want them to see, you know, is it going to be 4? We know what 4 is, but it's not the same length as 4. It's not the same length as 6. It's only ever going to be the same length as or equal to 5. And once the students built this themselves and they've seen it, and then we've walked through this concrete, then draw the representation, then write it in the abstract, we've got a very strong link between this concrete and, you know, knowing that this is a unit of measure. So this could be 2 guinea pigs and 3 guinea pigs. I bought, you know, I had 2, I bought 3. How many do I have? I've now got 5. Or, you know, I had 2 kilograms of bananas. We bought 3 more. I've got 5 kilograms now. So that understanding of number coming from a place of having progressed from counting into knowing addition. Okay, let me come back to sharing this again. And I might actually just use the images here. So you can see this here where I've just shown the same example that I had here, the 2 plus 3 equaling 5. It's the same length as. Okay, let me just progress a little bit faster. So as we said, the multiplication is fast addition. And then if we can multiply easily, division we can teach as fast subtraction. And once again, as I mentioned, we're just building rectangles and counting. So as you can see here, here's our 9 across and 3 high or 3 up. And basically we're seeing how many square units do we have inside that little rectangle that we've created. And if you can imagine being able to image or see, I mean, I was talking to somebody the other day and saying, you know, if we were to think of the best book that we read recently, it was a fantastic book because it enabled us to create images and have a multisensory awareness of what the author was talking about. So we're basically saying that's how we know we learn the best. And then progressing to fractions, to decimals, to percents. And basically seeing once we've got this model that we've used with our whole numbers, we're building rectangles, we can add, subtract, multiply, and divide. Now we can go to fractions and decimals and percents and still teach with the same ease and the same accuracy. So this is just a representation that you'll see of some of our manipulative that actually can show equivalent fractions. So you can see this is 1/3. Now we're going to divide that into 2 parts and then 3 parts and represent it as part of a whole. So we're showing much more accurately that 1/3 is the same as 2/6, 3/9, 4/12, etc. Yeah, pretty cool when you can show it this way. So let me just come back to, I'm just aware of our timing, we've gone over a little bit, but once we come back to these recommendations, what I'm hoping that you've seen is the pieces that I've talked about tonight, where we're going to screen the students with that placement testing and see where in the sequential model are they actually placed. Then we're going to teach with a focus on whole numbers, but in a sequence that's going to be accurate and really teach incrementally and teach from a place of establishing foundations first of all. We're going to make it multisensory, but use a consistent manipulative and use that accurate way of instructing and having the model that's consistent with the building a rectangle. We're going to teach explicitly and systematically and make sure that we're teaching very clearly and accurately. Have a cumulative review in every lesson and also have time for periodic testing that's already integrated into this approach. So really 4 steps where, you know, we've talked through this. We're wanting the teachers to have their professional development so that they understand a pedagogy and they're not dependent on a program, because as you know, programs will come and go, but if a teacher understands the deeper reasoning and research behind an approach, they're going to carry that with them into every lesson that they teach. And you can read through that as well. We're presenting them using that I do, we do, you do, and explicit instruction. We're practicing and having them practice, and then only progressing once we know that they've achieved mastery and they can apply this to their everyday life. So I know that was quite a bit, and I feel like I've done a whole heap of talking. I just wanted to share with you about these various trainings. So our Total Maths Mastery is more for people that are interested in becoming an intervention specialist or really leading. I'm in this school I mentioned in Nepean in Melbourne, where we have somebody who's the numeracy leader who's overseeing, and I'm working much more closely with them. So somebody who's a intervention leader in their school or as a tutor working and has students at all different stages. But basically that incorporates these 3 main modules. So what we refer to as our foundations of maths, then we progress to multiplication, division, and fractions, decimals, and percents. And just wanted to share with you. So this is at the URL, and I think we'll be sending an email out to you that will have an awareness, to have this link in it. And I just wanted to share with you, for those of you that have stayed till the end today, so if you do know that you want to join us and that you want to do training with us that is this accurate and it does actually incorporate these research-based recommendations, then there's a discount that we have for those of you that have stayed here until tomorrow midnight. Or if you do want to book a call and you have more questions and you want to book a time with myself, then we'll also send this link as well. But this is just gives you access to my calendar to be able to see. And then just let me come off this page and I'll just check if there are any questions. Okay. So thank you so much for staying on. I mean, there's still a few of us here, which is wonderful. Thanks so much. Very useful. Appreciate the free workshops. Fantastic. I know, like, you know, I was looking at this piece of these trainings and the free webinars and really looking at going, actually, I'm talking a lot about the same material, but, you know, when we look at these, you know, it's been interesting for myself over the last sort of 24 years, as I mentioned, and seeing, you know, back when there was all this research done in America, and they sort of say we sort of tend to take about 6 to 10 years to catch up with the research. And I'm seeing this part where, you know, particularly a response to intervention model, we're starting to become more aware of that and the research behind it. And then, you know, cognitive load theory, and then the Rosenshine's principles and explicit direct instruction. So really this piece where the training that we offer incorporates those components and enables you to have this understanding that then with the program that we have and with the additional components that we have in the training, that you can actually take this approach and actually bring it to your students with that ease of, you know, testing where are they actually up to. Now we're going to start at this point and progress them through and make sure that they have that understanding as we go through the maths. So let me just see if there are any questions. If anybody wants to unmute, super happy to if you have questions. Recall, there may be some specific resources for dyscalculia. Yeah, so I mean, I did a training with Dyscalculia Association in the UK. I suppose what I've seen is, you know, I think it's wonderful what's being done in terms of awareness for dyscalculia. I think the key piece that I'm seeing, though, is that there's still a need for us to teach more accurately than some are saying. Like I was on a call, for example, with this particular course, and one of the participants was saying, you know, I've got students struggling with maths, and the facilitator said, we'll just teach rote memorization. And I was just appalled. I'm like, you're working with students that don't have that capacity often. And, you know, when we have, as I hope you could see just from that little bit, the model where I'm building rectangles, you know, any child can build a rectangle and create an understanding and recreate that image for themselves to be able to learn maths easily. So I suppose I am talking more about dyscalculia, and I'm aware of, you know, one of the other pieces I saw was this gentleman, Professor Sharma, who talks about acquired, what he calls acquired dyscalculia, acquired difficulty with number, which just is what happens to a student when we don't teach them in the way that they learn, or when we don't teach them the way that we know we can teach a language the best. So acquired dyscalculia, or whether somebody actually has a developmental need there. But yeah, if there's a need for more talk on that, I'm happy to talk more directly to it. But yeah. Bev, she's got both integer set fractions, great to focus on. Wonderful. Yeah, so I'd say, Bev, if you're already using this approach or with the math you see, then the key piece is always focus on the concrete, because, you know, even in intervention, we tend to have a focus to go to the abstract. Like it's like we're rushing to the abstract component, where if we can hasten slowly and just take the time with the concrete, take the time to create understanding, then the abstract is so simple. It's like, you know, I can teach DOG is dog once I know what a dog is. If I don't know what a dog is, I'm going to have so much struggle trying to teach a child to remember those symbols. But if they've had that dog as their best friend, that's going to give them the opportunity. And, you know, as I said, the manipulative that we have in this approach where we're just building rectangles actually is able to be the foundation that they'll be able to recreate for themselves. Yeah, Brenda, can you get links to the new Maths New South Wales syllabus? I'm actually working with a specialist in Melbourne at the moment, and she's reviewing the version 9 of the Australian maths curriculum. And we're actually looking to do this for each of the, you know, differences between the states. But at the moment, we're looking primarily at that. But as you know, we do have some documentation that walks through our program, the Math UC at the moment, with the Australian curriculum and matches them. But primarily because we're using a mastery approach, the student's going to have mastered some material and they'll still cover the same material, but it will be from a place of mastery and understanding as they progress along. Marianne, thanks so much. Great. Okay, Bethany's put in the link to the training and the link to book a call. So, yeah, just wondering if there are any other questions. We're a smaller group now, so maybe you feel to ask a specific question about this to me at the moment while we're here. No? And so just wondering if you had any further questions. I know I've sent you some info recently, so great. Okay.
Thanks for
Okay,
sending us
great.
all that, Esther. It's wonderful. We haven't had a chance to look at it yet, but certainly we'll get back to you
Sure.
with any of our questions. But I think you've helped to put some bones onto what we're thinking as well. So hopefully we can be in touch.
Yeah, and so it was great to see. I was looking at your maths component from the with this on your website today, and just seeing, you know, the sequence of instruction that you actually have very clearly outlined. Let's teach counting, then place value, then addition, subtraction, multiplication, division. So really neat to see that that approach has been seen. It's just simplifies mathematics so much for our students. So yeah, fantastic. Great. Okay, well, I think that's it then, unless there's other questions. Thanks, Melinda. Great to see you here. Great. Thanks so much. Thanks, Karen. Thanks, Enza. Thanks, Bev. See you, Nicole. Bye, Marianne. Thanks, Bethany. Thank you, Karen. Thanks, Karen.